Okay, these are my test corrections for physics class. For multiple choice, number 2, a scientific fact is C, a close agreement by competent observers or observations of the same phenomena. Number 5, a scientific hypothesis may turn out to be right or it may turn out to be wrong. If it is a valid hypothesis, there must be a test for proving it that it is wrong. Number 8, suppose you are in a car that is going around a curve. The speedometer reads a constant 30 miles per hour. Which of the following is not true? C, your velocity is constant. Since velocity depends on direction, you're going around a curve, so your direction is not constant. Therefore, your velocity is not constant. Number 10, as an object falls freely in a vacuum, its velocity increases because acceleration is a constant. Number 11, a ball tossed vertically upward rises, reaches its highest point, and then falls back into its starting point. During this time, the acceleration of the ball is always directed downward because gravity plays a huge part in acceleration. Number 14, if you drop a feather and a coin at the same time in a vacuum tube, which will reach the bottom of the tube first? The answer is A, neither. They will both reach the bottom at the same time. Because it's in a vacuum tube, there's no air. Therefore, there's no air resistance to act upon the feather. And if there was air resistance, the feather would float like this, causing the coin to drop faster. So with the absence of air resistance, they will hit the ground at the same time. Number 16, which of the following would not be considered a projectile? The answer is B, a cannonball rolling down a slope, because there's no projection involved. It's just a ball rolling down a hill. Number 17, in the absence of air friction, the vertical component of a projectile's velocity doesn't change as the projectile moves. The answer is A. No. Wait, hold on. Yeah, the answer is A, always false, because gravity affects both of them. And number 19, a ball is thrown into the air at some angle. At the very top of the ball's path, its velocity is D, entirely horizontal, because at this point the ball is not moving up or down, therefore there is no vertical component, just horizontal. Moving on to the short answer. Number 4, a marble rolls off a 0.5 meter high table with a velocity of 1.2 meters per second. How far away from the edge of the table will the marble land? So I made a chart, and for X and Y, and in the X column, my X is what we're trying to figure out. The time is 0.32 seconds. The velocity initial is 1.2 meters per second. The velocity final is 1.2 meters per second. And the acceleration is 0 meters per second squared. In the Y column, my X is negative 0.5 meters. My time is 0.32 seconds. My velocity initial is 0 meters per second. My velocity final is 1.2 meters per second. And the acceleration is negative 9.8 meters per second squared. To find the distance in the X column, I plugged in my 1.2, which was my velocity initial, times 0.32 was the time, plus 1/2 0 times 0.32. The 1/2 times 0 times 3.2 cancels out, and you're left with 1.2 times 0.32, which is equal to 0.38 meters, which is how far it landed from the table. Number 5, a 0.1 meter tall cup is now placed 1 meter away from the edge of the table. How fast do you have to roll the marble to get it into the cup? I also made a X and Y chart. In my X column, my X was 1. My time was 0.29 seconds. My velocity initial was 3.45 meters per second. My velocity final is unknown, and my acceleration is 0. In the Y column, my X is negative 0.4 meters. My time is 0.29 seconds. My velocity initial is 0. My velocity final is unknown, and my acceleration is negative 9.8. To find the velocity initial in the X column, which is what we're looking for, I took 1 equals velocity initial times 0.29, which is the time, plus 1/2 times 0 times 0.29. Again, the 1/2 times 0 times 0.29 cancels out, and you're left with v initial times 0.29 is equal to 1. So you divide 1 by 0.29, and you're left with the velocity initial equaling 3.45 meters per second. And I will show my work right now.